Today we're gonna learn on 6.4 GSM, GPRS, UMTS, LTE, and 5G. Okay, so last we finished 1G anti-5G networks. Okay, jadi ya. Okay, so the cellular landscape concept lah. Alright. We have learned 1G anti-5G. And then next we will become on 6G 2030. Okay, dia punya target dia lah 2030 6G pula ke atas. Okay, so lebih kurang one decade for one generation. So remind us back 1G is for advanced mobile phone service UMTS and total access communication system text. Okay, so that is a foundation of land mobile radio communication. Okay, so 2G, so we recognize 2G as a GSM or Global System for Mobile. So that is a digital MPS in IS-65. So it started at 1992. 1G 1968 86 awal kan. And in 2004, will become the digital with 3G after 2G. So it's a wideband code division multiple access WCDMA. So it's for high speed packet access HPA and CDMA 2000. Okay, alright. So after that 2012 dah start dengan 4G dan ada masa tu ada long term evolution LTE advances. Okay, so kalau kata ada 3G kita pernah dengar HSPA kan, high speed kan, H plus kan. 4G kita dengar LTE, 5G apa agaknya. Okay, so kat sini kita ada 5G NR dan IMT 2020. Okay, so sekarang ni tengah test bed prototype trial and commercialization. Okay, so we release as release 15, 14 and 14, 15 and 16. So akan on 3GPP lah, right? So dia punya pernah dengar GSM, GPRS, UMTS, LTE, 5G mungkin akan dalam ni lah 5G NR, MT 2020. Okay. Boleh continue?
Boleh sir, boleh.
Boleh. Okay. Alright, so analog networks on 1G. Okay, so protokol yang kita nampak protokol tadi, MPS, data tag, FDMA, mobile tag, ATMT text. Untuk 2G kita pakai GSM protokol, okay, CDMA, IDEN, PC, TDMA 2.5G sebenarnya. Dia ada GPRS dengan H kan. Ini yang kita pakai yang paling popular sekali lah. Otherwise, other than GPRS and H, 2.5G ada CDMA 2000. CSCD and then widen. So you boleh tengok dia punya speed untuk every protocol kan. And then EGPRS ada dua. Second EGPRS we consider as 2.75G. Okay, so dia dah boleh bagi 1.2 megabit per second untuk download. Alright, so untuk 3G pernah dengar UMTS, okay. So lain-lain ada CDMA 2000, CDMA 2000 ada dua, AVDO, AVDV. Alright, and then CDMA 2000, AVDO, Rev A untuk AVDO kan. Division 0, Division A kan. Okay, so speed dia beza lah. Okay. Untuk 3.5G HSPDA, okay, kamu dapat H plus dekat NZ kan. Right. So it come up until 15.4 megabit per second. Okay. Alright, CDMA 2000 AVDO revision B. Okay, untuk 4G wired network equivalent to WiMAX, UMB, and then untuk LTE speed can up until 100 megabit per second. Alright. Ni yang tengah ada kan. Tengok GSM dulu. Sekejap ah. Saya tak tekan record ke? Ada. Kalau saya tak tekan record jenuh, kena ulang balik semua. Alright. So untuk GSM stand for Global System for Mobile Communication, developed by European Telecommunication Standards Institute or ETSI, a mobile radio standard for fully digital mobile radio networks, a successor to the analog system of the first generation. So most widely used mobile radio standard worldwide. So GSM is the popular 3G, 2G system lah. Alright, although there are many competing technologies in the 2G cellular network landscape, GSM by far dominates the world today with other 200 million users in over 100 countries. Okay, so sampai hari ni pun kalau kata dekat Malaysia ni, kalau kamu tak ada line 4G, tak ada, kita tengok ada 3G ke tak ada kan. 3G pun tak dapat, at least kamu ada 2G. Dia akan ada dekat handset kamu ada huruf E. Betul? Kan?
Betul saya.
H kan? Tu that is a 2G. Masih pakai lagi kita kan? Kat kampung-kampung kan? Right. Yang kata kampung pekan pun kadang tak ada kan? Dekat highway pun tak ada. Data rate up to 9.6 kilobit per second. Tapi macam tak ada langsung kan? Sebab sekarang penggunaan WhatsApp pun dah tinggi kan? So maksudnya teks mungkinlah dapat kan? Lain-lain tak dapat lah. Kalau kamu tengok TikTok lagi tak dapat 9.6 kilobit per second, tak dapat TikTok ni. Apatah lagi Bigo Live kan, lagi tak dapat lah. Using 124 channels per cell, each channel can support 8 users through TDMA, maximum 992 users per cell, in practice about 500. So it operates in following 3 frequency ranges. Okay, ada 3 frekuensi ya, 900, 1900 and 1800. GSM 900, GSM 1900, GSM 1800 kan. Okay. So untuk GSM yang 900 operates in 900 MHz frequency range and is the most common in Europe and the world. Okay, untuk 1900 ataupun 1900 ni, 1900, pieces 1900 DCS 900, 1900, the only frequency used in North America for GSM. Note that the term PCS is commonly used to refer to any digital cellular network operating in the 1900 MHz frequency range, not just GSM. So untuk GSM 1800 or 1800, so term dia adalah PCN DCS 1800. So operates in the 1800 MHz frequency range, and it found in rapidly increasing number of countries including France, Germany, Switzerland, and UK and Russia. Okay, so there are dual band and tri-band phones are available to provide support everywhere. So untuk GSM roaming support, okay, apa benda ni? So let us assume that you have a single band GSM 1900 phone. So this phone will only work in North America kan? But after landing in Europe, you can transfer your SIM or subscriber identifier module, SIM card, okay, to a phone to the correct frequency. So this is called SIM roaming. It means that once you arrive in Europe, you must rent a GSM phone from a local network operator so that you will have the phone that use the correct frequency. Then you simply take the SIM out of your home phone and insert it into the rented phone. Please do remember to take your SIM card back kan. Okay, SIM roaming offer the advantage of letting you use your home phone number and being billed to your home account. Make sure that your local network operator has a roaming agreement with a destination country. So many North American companies have roaming agreement with country abroad, or some do not. Okay, so tapi charges mahal lah. Kalau kamu duduk dekat Kelantan kan, pergi sebelah sana Golok kan, sebelah sana kan dia ada roaming kalau kamu pakai pakai Celcom ke kan, Maxis ke, tanya saya pakai Celcom, saya pergi Naratiwat, dia nak roaming ke tak payah pakai lah, kan mahal. Kalau saya sampai dekat Australia pun, saya tukar SIM card lah, saya tak pakai SIM card, tak pakai nombor saya, senang. Kan pakai je nombor dia orang, kan, beli nombor dia orang. Senang. Dia orang pun datang Malaysia pakai nombor Malaysia kan, tak pakai roaming ni. Okay, certain boleh pakai lah, tapi dia kena crack number. Tapi untuk GSM dulu pun, kan, kalau pakai phone yang tak sama, tak support lah. Macam kita tak ada phone 5G, tiba-tiba nak pakai line 5G, tak dapat lah kan. Kalau sama je masa LTE mula-mula keluar kan, ada phone yang tak support LTE kan. Line dah ada LTE, phone pula tak ada LTE kan. Bila pakai phone LTE, rupanya singkat pun tak ada LTE kan. Ataupun line, apa nama, coverage ada LTE, tapi kamu tak beli package yang LTE punya untuk Celcom ke masa mula-mula tu kan. Kena beli kan, kena tukar. Alright, so untuk GSM Network Architecture, so dia ada mobile station and base station subsystem. BSS lah macam base station lah kan, okay. So mobile station represent the mobile user and communicate across the air interface, okay, with the base station transceiver in the same cell as the MS. So the main part of MS is mobile equipment, ME, telephone or PDA. So ME ataupun mobile equipment ni includes a radio transceiver, a digital signal processor and a subscriber identity module ataupun SIM. SIMs are used to support roaming. So untuk base station subsystem consists of base station controller, BSC and the one more base transceiver station or BTS, bukan K-pop tu kan. So each BTS defines a single cell and includes radio antenna, radio transceiver and a link to a base station controller or BSC. So BSC reserve radio frequencies, manage handoff of mobile units from one cell to another within BSS and controls paging. Okay, so MSC pula, okay, Mobile Switching Center, provide link between cellular network and public switched telephone network. Kalau telefon handphone nak telefon rumah kan, atau telefon pejabat kan, so kita guna MSC, Mobile Switching Center, MSC. So MSC control handoff between cell in different BSSS, so authenticates users and validate accounts, enable worldwide roaming of mobile users. To support this feature, MSC consists of following database. Macam kita dah ingat sebelum ni kan, untuk cellular kan, kita ada home HLR dan VL home location register, database store information about each subscriber that belongs to it. VSL adalah maintain information about subscriber certificate in the region country. So dia duplicate lah, dia copy kan. Okay, authentication center AUC database ada, used for authentication activities, whole encryption, key and equipment identity register ataupun EIR adalah database to keep track of the type of equipment that exists at the mobile station. Alright, so kita tengok tadi ada ME dengan SIM, okay, ada ME SIM, okay, so base station kita BTS dengan BSC. Alright, so kita ada MSC, okay, MS, BSS, MSC, ada database HLR dengan VLR yang kita belajar, dan juga untuk EIR, okay, Equipment Identifier Register untuk nak tengok dekat satu-satu tempat tu dia siapa yang ada kan, AUC. Kemudian kalau kata nak telefon ke telefon rumah, so kita ada connection to PSTN, Public Switched Telephone Network. Okay, clear. Alright, so that is GSM 2G architecture dalam bentuk kotak ni lah kan, diagram sama je macam tadi. Okay, untuk 2G CDMA cellular IS95, okay, has different structures for its forward base station to mobile station and backward link. So the forward link consists of to 64 logical CDMA channels, each occupying the same 1228 kHz bandwidth. So the forward channel supports 4 different types of channel: traffic channel, pilot, synchronization, and paging. Okay, so for traffic channel, channel 8 to 31 and 33 to 63, these 55 channels are used to carry the user traffic, originally at 9.6 kilobit per second, revised at 14.4 kilobit per second. Untuk channel 0 ataupun pilot, so used for signal strength comparison among other things, so to determine handoff. Nanti kita akan ada 6.5 handoff. Kelas 4. Okay, synchronization on channel 32. Dia berhentikan sampai 31 kan. Tengah-tengah 32 adalah for synchronization. So 1200 bit per second channel used to identify the cellular system ataupun system time protocol revision for and etc. Okay, ingat yang kosong pilot, lepas tu channel 1 sampai 7. Okay, 8 tak guna kan. Satu ni pilot, yang 7 lagi adalah paging. Channels 1 until 7 for message of mobile station. All these channels use the same frequency band. The chipping code, okay, 64-bit code is used to distinguish between users. So those 64 users can theoretically use the same band by using different codes. So the voice and data traffic is encoded, assigned a chipping code, modulated, and sent it to destination. So dia pakai CDMA kan. So the overall architecture of 2G CDMA based system are similar to TDMA based GSM system. So the main difference is that the radio communication between the base station, subsystem, and mobile station use CDMA instead of TDMA. Ada figure 8.10. Tak ada, tak keluar sini. Alright, so untuk CDMA advantage, network capacity in CDMA, the same frequency can be reused in adjacent cell because the user signal differentiate between each other by code. So those frequency reuse can be very high, and many more users, up to 10 more time more, can be supported as compared to TDMA. So reliability and graceful degradation. Ada azan pula. Sekejap. Alright, so kita sambung. Tadi azan lah. Okay, saya
Okey.
tengok pun slide pun banyak lagi. So kita cepat-cepat lah saya ambil advantage. So ada network capacity. So nanti you baca dia punya description dah, boleh ya. Alright,
Boleh
so
saya boleh.
reliability and graceful degradation. Selain itu, for privacy, frequency, diversity and environmental. So semua adalah for CDMA advantages. Okay, so dia ada disadvantages pula kan. Okay, so dia ada self jamming and then soft handoff. Okay, kita nak masuk ke GPRS pula. Okay, ini coverage untuk GSM yang memang popular lah. Sebelum tu kan tengok GPRS, GSM. Okay, banyak pakai kan. Malaysia fully utilized kan. Okay, so ada dah tempat yang discontinue of GSM kan, macam Australia and Singapore kan. Malaysia belum lagi kan. Okay, so lain ada tempat Germany, Australia, Switzerland 2021. 2022 saya rasa lebih banyak yang dah discontinue of 2G. Kita kalau tak ada 2G langsung tak ada internet kot kan. Okay, and then ada GPRS. Alright, so GPRS 2.5G. Wireless cellular network have been developed as transition pass to 3G. Sebelum 3G, okay, this system build packet switching system on top of existing 2G system to improve data rates significantly. Tujuan dia untuk improvekan data rate. Okay, GPRS ni adalah General Packet Radio Service. So GSM networks offer secret switched data service at 9.6 kilobit per second. So most GSM carriers are developing a service called General Packet Radio Service GPRS or 2.5G technology. GPRS can theoretically provide IP-based packet data speeds up to a maximum of 160 kilobit per second. Okay, however, typically GPRS network operate at lower data rates. One proposed configuration is 80 kilobit per second maximum ataupun 59 kilobit per second typical for the downlink and 20 kilobit maximum 14.4 kilobit typical for the uplink. So kalau kau tengok sekarang ni macam tak relevan kan, kecil kan, tapi inilah realitinya masa mula-mula sebelum 3G kita ada GPRS. Okay, so saya cepatkan, kamu baca yang bawah ni boleh. Alright, so GPRS service offered extend the GSM packet secret switch data. So dia ada MMS masa ni, SMS messaging and broadcasting. Sekarang dah tak pakai, semua pakai WhatsApp kan. Real time location based service such as direction, basic multimedia, short audio lah, video clip, game and image, and then ada WAP. Pernah dengar nama WAP dulu kan? Wireless Application Protocol ataupun Internet Application for Smart Device through Wireless Application Protocol. Semua tinggal kenangan sekarang ni ya. Alright, so ni architecture dia lebih kurang yang tadilah kan. Kamu cari perbezaan dekat sini. Okay, so ada habis kan. Alright. So dia punya untuk tengah ni ataupun kita panggil network subsystem. So ada banyak lagi ya. So dia ada PSTN dengan PSDN. Tadi tak ada kan. Okay, so dia ada GSN, serving GPRS support node. Okay, dia ada gateway lah, GPRS support node. So VLR dan HLR ada, jangan risau kat sini kan. Kemudian GPRS yang kata enhance tu ataupun kita panggil H tu sebenarnya dia adalah Enhanced General Packet Radio EGPRS kan, was deployed on GSM network beginning in 2003. So improve data transmission rates at a backward compatible extension of GSM. So H is a superset of GPRS and can function on any network with GPRS deployed on it or speed up to 135 kilobit per second. Kan? Tinggilah sikit kan? Bolehlah tengok apa nama teks kan. Okay, also known as 2.75G and it also can be considered as 3G technology ataupun kita panggil enhanced data rate for GSM evolution. Itu maksud dia H. Kan? Enhanced data rates for GSM evolution. GSM evolution. Ingatlah H. Okay, so continue lagi cellular network, kamu baca. Saya nak cepat ni. Okay, so yang technical part lah, kita ambil technical part. H, enhanced data rate for GSM evolution can generally be considered as 3G technology sebagai macam tadi kan. Okay, so introduce new method of at the physical layer including a new form of modulation. Kita pakai 8 PSK and different ways of encoding data to protect against error. Maximum rate macam kita tengok tadi 384 kilobit per second. Each has been designed to address some of the implementation of GPRS. Okay, so for example, GPRS impact network existing cell capacity because both and GPRS call both use the same network resources. Okay, so continue. Tanya yang technical. Alright, so H require a number of new element to be added to the system. Okay, 8 PSK modulation tu kan. Right. So in order to achieve the higher rates data rate within GSM-H, the modulation format can be changed from GMSK to 8 PSK. So this provides a significant advantage in being able to convey 3 bits per symbol, thereby increasing the maximum data rate. So base station, apart from the upgrade to incorporate the PSK modulation capability, other small changes are required to the base station pun ada changes. So these are normally relatively small and can be often to accomplished by software upgrade. So apa itu 8PSK? Harap ada ni. Ingat balik kan apa nama 8PSK? Cerita apa kita tengok? Frekuensi kan? Okay, H upgrade to network architecture. GSM H provide the capability for IP-based data transfer sebenarnya kan. As a result, additional network element are required such as gateway, GPRS atau tadi kan GSN kita tengok dalam diagram tadi. Okay, architecture tadi connects to packet switch network such as internet and other GPRS network. Okay, satu lagi dia ada service GPRS service network ataupun SGSN. So it will provides the packet switch link to mobile station. Okay, so benda ni lah yang kamu boleh call daripada internet ke telefon biasa kan. Alright, so mobile station it is necessary to have GSM-H handset that is H compatible. Samalah handset dulu-dulu kena ada H baru boleh pakai H. Tapi sekarang ni semua dah ada H, jangan risau. Kan? Okay, ni macam kita nak pakai 5G kena ada telefon 5G. Okay, ini dia punya specification. Dia multiple access technology adalah FDMA and TDMA. Yang tadi pakai CDMA kan. Duplex teknik FDD channel spacing 200 kHz. Modulation kita pakai 8 PSK kan. Yang mula-mula pakai GMSK. Slot per channel of course 8. Frame duration 4.615 millisecond. So latency, symbol rate, modulation bit rate semua ada kat sini ya. Kita tengok radio data rate, maximum user data rate and maximum data rate using 8 time slots. Okay, habis GSM dan GPRS, kita masuk pada 3G iaitu UMTS. So UMTS is Universal Mobile Telecommunication System. So it is one of the third generation 3G mobile phone technology. Selain daripada kita belajar SSPA kan, 3.5G kan. So kita ada UMTS dulu. So it is standardized by 3GPP and it is the European answer to the ITU IMT2000 requirement for 3G cellular radio system. So it is an evolution of GSM technology. So UMTS is the 3G successor to GSM which utilize the WCDMA air interface and GSM infrastructure. Ya. So the overall idea is that UMTS user will be able to use 3G technology all over the world under different banners. So this roaming ability to use devices on different network will be made possible by satellite and land-based network. So maksudnya telefon, chip, semua kita nak standard dah kan lah. Waktu nak pakai 3G ke tak. Jadi macam tadi kan, nak roaming pun susah, apa semua susah. So macam mana nak buat? UMTS provide a consistent service environment even when roaming via virtual home environment ataupun VHE. So a person roaming from his network to other UMTS operators experiences a consistent set of services independent of the location or access mode ataupun daripada satellite or terrestrial. So designed to rise the data rate to 2 megabit per second. Puas hati sikit kan? 144 kilobit per second when driving. Waktu driving slow sikit lah. Okay. Okay. Kalau driving, kalau berjalan dapat juga dalam 384 kilobit per second. And then untuk duduk still kat rumah pakai laptop tu 2 megabit per second for indoor. So ada two types of UMTS system. Frequency Division Duplex FDD. Okay. So wideband code division multiple access FDD under WC DMA. So it use two frequency which allows separate transmission and reception on two different frequencies. And another one types is a time division duplex ataupun TDD. So it wideband code division multiple access. So under TDD under WC DMA. So it will allow for duplex transmission on the same frequency by assigning different time slots in a single frame for transmission and reception. So UMTS combines the WCDMA, TDMA, CDMA technology ataupun air interface. Ada lagi GSM Mobile Application Part, MAP Core and the GSM family of speech codes. So in the most popular cellular mobile telephone variant of UMTS, WCDMA is currently used. So UMTS over WCDMA use a pair of 5 MHz channels. In contrast, the competing CDMA 2000 system use one or more arbitrary 1.225 MHz channel for each direction of communication. So use spread spectrum technology, it assign different codes to user as in CDMA. Sebenarnya pakai kod kan. So architecture dia masih ada SGN, GSN kan yang tadi kan pakai GPRS. Alright. Sama tak? Lebih kurang sama kan. Cuma dia ada 3G UE. Dia boleh pakai 2G yang dan 3G UE. Alright. So network element dia ada MSC, Mobile Switching Center. Okay, serve ME at current location for switch circuit switch service. Pada ada MSC dan GMSC. GMSC is gateway MSC. So serve UMTS when it's connected to external CS NW. Okay, MGW adalah media gateway perform actual switching for user data. SGSN yang tadi serving GPRS support node. GGSN gateway servicing GPRS support node. And node B adalah 3G base station handles radio channel multiplex and the multiplex of data and voice. RNC adalah radio and network controller, control and manage multiple base station. UE untuk UMTS is based the same principle as the GSM MS, the separation between mobile equipment and UMTS subscriber identifier module. Masih pakai SIM card ataupun SIM. So UE consists of display and user interface, hold the authentication algorithm and keys, user and termination of the air interface and application platform. Spectrum untuk UMTS spectrum bandwidth is 5 MHz. Spectrum specified by WARC 92 is 1900 MHz for uplink and 2100 MHz for downlink. Download lah kan. For over 120 licenses have already been awarded to operator worldwide as of December 2004, specifying WCDMA radio access technology that based on GSM. Okay. Ni dia tak ada terang kan. Sikit kan. Macam tadi kan. Panjang kan. Speed apa, high ni kan. Okay. Advantages over GSM and CDMA. Speed, high spectral efficiency, Third one, global roaming, good network coverage, and last, a better quality of service. Drawback ada tak? Ada. So UMTS is criticized, okay, kena hentam kan, okay, for its wide spectrum. So cost of license for its spectrum is very high, mahal. Deployment of UMTS require upgradation of existing GSM network, which is very costly. UMTS network require base station at every 100 meters, which is not possible in urban areas. So sebab tu kampung-kampung tak ada UMTS ni kan. Sebab nak kena ada pencawang tiap-tiap 100 meter kan. Kena ada pencawang kan. Base station. Now we go to LTE pula. 4G kan. Waktu 4G kan. Ataupun nama panjang dia adalah Long Term Evolution Network. So a project by Telecommunication Body named Third Generation Partnership Project 3GPP. So SAE adalah System Architecture Evolution is the correspond of GPRS 3G Packet Core Networks Evolution. So LTE represent both LTE and SAE sebenarnya. So the main goal is to provide the high data rate, low latency and packet optimized radio access technology supporting flexible bandwidth deployment. So the network architecture design which go to support packet switched with seamless mobility and great quality of service. Okay, architecture dia lain. Beza kan dengan tadi yang banyak-banyak kan. Alright, so the evolve U-Trend, EU-Trend. Alright, so dia ada juga MME, Serving Gateway, PDN Gateway, nampak tak? Sama kan? Ada, masih ada. Alright. Tapi nampak macam sikit lah. Main feature of LTE technology, real-time services. LTE equipped with TCP IP layer that makes it an all-IP network. So the technology support things like voice, video, mixed data and message in traffic. Then TCP IP layers adalah main feature LTE juga. So LTE allows to use any bandwidth and capable of getting paired with both TDD and FDD bands. So spectrum flexibility, okay, offer protection and give ability to shape the radiation transmission patterns. Advantages. IP network architecture used by LTE networks makes it fully dedicated to the packet switched operation. So the voice transported using voice over IP and legacy network. So LTE use OFDMA kan, in the downlink by effectively utilizing the channel resources, resulting in increasing the total user capacity because different users utilize different channels for using the system. So kalau maksudnya utilize channel resources, maksudnya tak ada orang pakai, kita boleh dapat laju lagi lah kan. Come with better version of architecture when compared with other standards, so the handoff become much smoother between regions. And nampak, faster downloading that reduce traffic load on the network. The advantage of LTE. Okay, disadvantage dia or drawback. So I think it's a little bit complex and demand highly skilled engineers for managing the system. Of course lah kan. And then forcing in making the LTE technology costly when compared with standard network. Tapi kalau kata orang fokus betul-betul benda ni, kan, mau kan. Benda tu pergi kursus je. Kan. Right. So engineer akan tambah ramai. Older model of phone cannot use LTE technology. Ni dululah waktu mula-mula. Banyakkan telefon tak boleh support LTE, betul tak? Kan tak ada lah. Supposed to be okay. And now we moving to 5G. Okay, nowadays providing a new frequency bands along with the wider spectrum bandwidth per frequency channel. So this difference between 4G and 5G, high increased peak bit rate, larger data volume per unit area ataupun high system spectral efficiency, high capacity to allow more devices connectivity concurrently and instantaneously. So lower battery consumption, nampak? Better connectivity irrespective of the geographic region in which you are, larger number of supporting devices, lower cost of infrastructure development, higher reliability of the communication. Ambil lagi tengok lagi banyak kan. Okay. Dia kena perbesar ni. Tak nampak kecil-kecil ni. Alright, so kamu baca dia punya, cepat kamu tengoklah dia punya nama-nama dia lah. Okay. So kalau tengok sini ada nama IoT kan. Nampak? Kita guna. Okay. Ada nama MIMO. D2D communication. Kan? Alright. So application of 5G. Ni kamu baca lah. Application je kan. Alright, ni kita tengok yang tadi ke advanced features of 5G, particularly it possible to available the super speed 1 to 10 gigabit per second. Alright, so saya kita orang baru beli je 10 gigabit switch kan. Tu yang wired. Wireless dah ada dekat 5G, nampak kan. So latency will be 1 millisecond. Okay, kecil lah kan. And then bandwidth 1000 times bandwidth per unit area, feasibility to connect 10 to 100 members of devices. Worldwide coverage about 19 reduction in network energy usage. Dan of course battery life will much longer. Tu yang penting kan. Sebab semua orang nak kena charge kan. Charge bukannya stick pada current fix kan. Tak. Pakai bateri. Okay. So, kamu baca advantages of 5G. And then disadvantages. Kita pergi yang technical je kan. Habis. Tak apa, baca sendirilah. Kita masuk ke 6.5. Okay. Propagation Effects and Handoff. Alright. Boleh ya?
Boleh,
okay.
sir.
So nanti you habiskan advantages of 5G, disadvantages of 5G. Okay, clear? Alright, ready.
Clear, sir.
Okay, 6.5 ataupun yang last, kita ada propagation effect and handoff. Okay, kalau kita tengok sini, ada dua sel I dengan sel J. Ingat sel tu apa? Alright, so kita tengok ideal boundary adalah tengah-tengah dia yang mana signal dia sama banyak. Betul tak? Tapi kalau kita pergi sebelah, dia dah reduce strength sebelah J. Kalau kita duduk belah sini, strength kita dekat sebelah I. So dia akan ada bertukar-tukar. Right. Okay. So ini kita panggil dia signal strength versus fading. So strength of signal between BSS and mobile unit needs to be strong enough to maintain signal quality. So not too strong so as to create co-channel interference mass render variation in noise. So sebab apa kita pakai sel? Sebab kalau kata signal kita tak strong, kita akan masuk ke sel sebelah. Kan? Betul tak? Sebab tu dia kena maintain dia punya pencawang tu jangan ada gap kan? Okay? So supaya kita dalam bentuk sel. Ataupun lebih tepat dalam bentuk honeycomb tu kan? Walaupun sebenarnya dia bulat, tapi kita nak senang measure dalam bentuk honeycomb tu. Ataupun hexagonal. Okay, fading pula bila berlaku? Fading berlaku bila? Okay, rapid fluctuation of received signal strength over short time interval and or travel distances. So time variation of received signal caused by change in transmission path. So even if signal strength is in effective range, signal propagation effect may disrupt the signal. So fading signal occur due to reflection from ground and surrounding building, clutter as well as scattered signal from trees, people, towers and etc. Okay. Ada jenis-jenis je kat fading kan. Untuk fast fading, rapid changes in strength over half wavelength distances. Slow fading is slower changes due to user passing different height, buildings, gaps in building and etc. Untuk flat fading, effect of frequency in same proportion simultaneous. Selective fading is different frequency components affected differently. Okay, kita ada small scale fading based on multiple pass time delay spread, ada satu lagi based on Doppler spread. Okay. Kalau untuk multiple time delay spread, kita ada flat fading dengan frequency selective fading. Boleh tengok flat fading bila bandwidth of signal kurang daripada bandwidth of channel. So ataupun delay spread kurang daripada simbol period. Kalau lebih bandwidth of signal more than bandwidth of channel, so it will be frequency selective fading, ataupun delay spread more than simbol period is frequency selective fading. Untuk based on Doppler spread, sama ada dua lah, fast fading ataupun slow fading. So high Doppler spread, coherent time kurang daripada simbol period, and channel variation faster than base band signal variation. Untuk slow fading, so low Doppler spread, coherent time more than symbol period, channel variation slower than baseband signal variation. Okey, kita akan masuk ke propagation effect sekejap . Alright, so on propagation effect kita ada reflection. So reflection occurs when a wave impinges on an object that is moved, which means that any protrusions have dimension much larger than a wavelength. So reflection is often accompanied by refraction, okay, transmission of the waves through the object. So the strength of the reflected and refracted wave often depends on the type of material. So the angles and index of reflection are given by Snell's law. Okay. Satu lagi scattering. Scattering is what happens when a wave impinges on an object that is rough and or has irregularities with dimension on the order of the wavelength. It is similar to reflection but result in a smearing of the signal around the angle of reflections. So this leads to a larger loss of energy as the signal is spread over a wider area. It also results in multiple paths arriving at the receiver from a similar location with slight difference in delay. Diffraction adalah bending of waves around shaped corners. Important example of diffraction include wave bending over the top of building, around street corner and through doorway. So diffraction is one of the main ways that is possible to provide coverage, cellular coverage in 60, and is one reason why lower frequencies, say less than 3 GHz, are considered beach front property in the world of cellular spectrum. Okay, and kita masuk last, handoff. Handoff ni maksudnya nak tukar base station ke base station lain kan. Okay, a crucial component of the cellular concept is the notion of handoff. Mobile phone user are by definition mobile. They are move, sebab nama pun mobile. They move around while using the phone. Nama pun mobile kan. Thus the network should be able to give them continuous access as they move. Jangan ada terputus. Kalau kita tengah bercakap dalam kereta kan, jadi jangan terputus. So that is concept of mobile. Macam mana nak buat? Padahal kita dah masuk ke pencawalan. Okay, nama dia handoff. So this is not problem when user move within the same cell. When they move from one cell to another, a handoff is needed. Okay, macam mana handoff? Kita akan tengok view on strength lah. Strength tadi kan BS1, BSI dengan J. Macam mana dia nak tukar apa nama sel tu kan, ataupun BS tu kan. Okay, so ni contoh tengok ada kereta, dia masih lagi strength dia kat mana kan. Okay, bila dia dah tukar, so dia akan pergi dekat BSJ pula kan. Okay, by looking the variation signal strength from either base station, it is possible to set an optimum area where handoff can take place. So kita ada dua jenis handoff, hard handoff and soft handoff. Hard handoff in cellular communication, the term hard handoff refers to the process of transferring an ongoing call or data transition from one channel connected to the core network to another. With hard handoff, the link to the prior base station is terminated before as the user is transferred to the new cells base station. The cut connection yang lama kan, kita panggil hard handoff. Tak ada nak masuk yang baru lagi, daripada sel I ke sel J, dia terus cut yang dekat sel I. Okay, sel J tak sempat masuk lagi, dia dah cut. So kita consider as hard handoff. So that the mobile is linked to no more than one base station at a given time. Initiation of the handoff may begin when the signal strength at the mobile received from base station 2 is greater than the base of the base station 1. So, satu lagi kita panggil soft handoff in cellular telephone communication. Soft handoff refer to the overlapping of repeater coverage zone so that every cell phone set is always well within range of at least one repeater or so-called base station. So, dia dah consider as dia duduk dekat dua sel. Sebelum dia nak bertukar ke satu sel tu, maksudnya dua-dua masih ada lagi, dia belum cut. In some cases, mobile set transmit signal to and receive signal from more than one repeater at a time, so soft handoff is beneficial because it reduces interference into other cells and improve performance by using macro diversity. So of course, soft handoff is improve performance. Okay. Also, soft handoff can extend coverage area, mitigate. Alright, so how cellular phone works with handoff? If one of mobile unit move from one cell to another during the call, then handoff processing takes place. So the mobile unit detect and select the BTS with the strongest control signal as its home cell. So the selected BTS inform the MSC about location of the user. The MSC then register the user in the direction of indicate its location. Jangan ingat senang dia nak tukar daripada satu sel ke satu sel. So dia akan register balik macam mana kita mula-mula connect dengan BS tadi kan. Okay. So the user is assigned a new channel in the new cell and now the call are routed to the new cell. All this processing take place without any interruption. Okay. Nak kena pastikan handoff ni take place without any interruption. Sebab dia nak tukar ke BS atau BTS yang baru, MSC semua kena tahu location baru, kemudian dekat tempat baru dia akan dapat new channel kan, semua kena smooth lah. So we need a handoff strategy when a mobile move into a different cell while a conversation is in progress. The RNC automatically transfer the call to a new channel belonging to the new BS. The handoff operation not only involves identifying a new BS but also requires that the voice and control signal are allocated to channels associated with the new BS. So processing handoff is an important task in any cellular network. So yang penting dia nak tengok kalau tengah bercakap dengan telefon kan, terputus tak kan. Kalau ada sekejap je lah dia punya gap dia kan, supaya tak terasa sangat kan. Kalau tak nanti kenapa tak jawab, rupanya tengah ada berlaku handoff kan, nampak macam tak terputus lagi kan. Okay. Yang tak nak terputus connection tu satu hal kan, tu macam biasalah, maksudnya internet pun tersedapat lah kan. Many handoff strategy prioritize handoff request over call initiation request. So handoff must be performed successfully and as frequency as possible and be imperceptible to the user. Kalau tak nama mobile phone tak gunalah kalau kata tak boleh mobile dan take place dia ada problem, ada lag, ada gangguan kan, kadang terputus, so tak nama mobile phone lah. Macam smartphone, kalau tak smart tak nama smartphone lah kan. Right. Okay, in order to meet this requirement, we must specify an optimal signal level at which to initiate the handoff. Okay, sambung balik yang tadi. Once a particular signal level is specified as a minimum usable signal for acceptable voice quality at the BS receiver, a slightly stronger signal level is used as a threshold for handoff. If the gap given by ni delta, okay, tanda apa nama segitiga ni, piramid ni kan, piramid Kita panggil dia data cannot be too large or too small. If data is too large, unnecessary handoff which burden the RNC may occur. So if data is too small, there be insufficient time to complete handoff because a call is lost due to weak signal condition. Tu bahaya. Jangan ni. So kena maintain So therefore, data is very important. Calculation lah. Kan? Okay. So in deciding when to hand off, it is important to ensure that the drop is measured signal level is not due to momentary fading and the mobile is actually moving away from the serving BS. Masa mana nak tukar tu? Kan? Siapa nak ambil? Siapa yang nak initiate kata kita akan buat hand off ni, kan? Kan? So maksudnya dia ada lah. Kena ada timing dia lah untuk nak buat handoff. So hence the BS monitor the signal level for certain period of time before handoff is initiate. Siapa yang monitor? Base station. Dia yang akan tentukan tadi. So the length of time needed to decide if a handoff is necessary depend on the speed at which the vehicle is moving. So jangan risau, dia pun macam AI je kan. Ada yang speed laju, ada yang speed biasa jalan kaki. So dia tak kalut sangat kan. Okay. So this data can be determined from the statistic of the uplink fading signal at the BS. Okay, so kamu bacalah nanti handoff is first generation 1G. Waktu mula-mula 1G macam mana handoff. 2G tak? 2G 1G and 2G je. Sejarah ni. Okay, so yang ni baca. Okay. Yang penting kamu kena tahu RSSI tu apa. Ni penting, kita budak network kena faham dia punya technical part kan. Alright. Okay, so habis 6.5. Okay, good luck, selamat membaca. Baca dekat buku teks lah. Kan? Buku teks saya dah bagi kan?
Ada, sir.
Alright.